Hi everyone, and welcome to this series of solving different circuit practice problems. This is the first question. We will be using the mesh analysis to analyze this circuit. Now we will have different scenarios. This scenario will have only independent sources. So we'll have an independent current source and an independent voltage source. And you see here the current source is basically in a branch on the side of the circuit in the loop, but it's only in one loop. It's not shared between multiple loops. We will see what will happen if the current source is shared by multiple loops. So the question is asking us to find V out. What is the output voltage for this circuit? But as we used to do in nodal analysis, where the objective was, first we need to find the node voltages using KCL, and then we can find anything else required in the circuit. Here, we will basically doing the same thing, but we will be looking for loop currents. And once we basically find these loop currents, we will find any voltage or any current or any power in the circuit. So the first thing we need to identify is to identify the loop currents. So basically we have here one loop current, we call it I1. A second loop current is I2. A third current is I3. So these are the three independent loops. They are nothing shared between these loops. So each current is identified in that loop. Now, these currents are sort of imaginary current, not measurable currents. There is nothing called a current that goes in the loop like this. For example, the current that goes here, this current, let me call it I. This I is basically I1 minus I3. This I is the measurable current, but the loop currents are basically imaginary current. We use them only for solving the circuit. So we have three loops, three loop currents. So we need to come up with three equations to solve these loop currents. Now, whenever there is a loop that has a current source, we do not apply KVL to that loop. Why is that? Because we don't know the voltage here. The voltage cannot be expressed as a function of I1. Then we have to identify another unknown. So we are increasing the complexity of the equation. Instead of having three currents, we will have three currents and a voltage. So basically, we do not apply KVL to that loop. However, we can extract a very important information. Now, as you can see, I1 is the current that is assumed to going this way. So this I1 in that specific branch, which has the 2 milliamp, I1 and the 2 milliamp are exactly the same current. So from loop number one, basically what we can say that is your I1 is equal to 2 milliamp. And that is my first equation. Now, when you go to loop number two, we can find two resistors and a voltage source. Now we can apply KVL. So we will apply KVL to loop number two. So now we will move from this point, go clockwise. We go with the same direction as the current that is in that specific loop, and the same direction of the current. So since the current is clockwise, we will go clockwise. Now we come here to the voltage across the 2 kilo ohm. Now, of course, I2 will be in the direction of the assigned polarity. I1 is in the reverse direction. So we will have 2K times I2 minus I1 plus the voltage here, 2K I2 minus I3. I3 is the current in the opposite polarity. Then minus 12 is equal to 0. I can basically divide everything by 2. So we'll take this 2 out, and this becomes 6. Now, let me open the bracket. So we have 1K I2 minus. Now, I1 is 2 milliamp, is a known value. I don't need to keep calling I1, I will put its value. So we have 1K times 2, so this becomes equal to 2. The milliamp will cancel with the K, plus another 1K I2 minus 1K I3. Now minus 6 here equal to 0. So we will have 2K I2 minus 1K I3 is equal to 8. And that is my second equation. Then we will go for I3. Okay. Now my I3, again, we'll go through the loop. Now the direction of the KVL will be basically going clockwise with I3. So the polarity I assumed in the previous step will be erased. We will have now a different polarity. So this is something very, very important to each time you will have a different polarity. So let's start from this point. So we will have plus, so KVL to loop number 3. So we will have 4K I3 plus, the polarity here now becomes plus minus. Again, we'll follow the direction of the current in that specific loop. So plus 2K I3 minus I2 plus 2K I3 minus I1, which is 2 milliamp, minus 2 milliamp is equal to 0. So let me collect terms here. So we will have 8, 2, 2. So we have 8K I3 minus 2K I2 is equal to 4, and that is my third equation. Now, when you look to the second equation and the third equation, if I add them, I can eliminate I2. So we add equation 2 plus 3. Now it becomes math. Now, whatever technique you want to use, that's okay. So we will have basically here minus 1K I3 plus 7K I plus 8K I3. We'll have 7K I3, 2K I2 minus 2K I2 done is equal to 12. So your I3 is equal to 12 divided by 7K, or 12 over 7, because we are dividing by 1,000, it becomes milliamp. So that is your I3. Now what I want to find, I find V out. But what is V out? V out is nothing but 4K times I3. So it is 4K times 12 over 7 milliamp. The milli will cancel with the K, and this will give me a voltage equal to 48 divided by 7, or equal to 6.86 volt. So this is how we handle a basic, I would call this is a basic mesh analysis question.